Welcome viewers. In this lecture we will be looking at solved problems and definition of terms on the following topics: what they mean by cell and battery, series and parallel arrangement of a battery, series and parallel arrangement of a resistor, solve problems on Ohm's law, definition of terms in terms of resistivity and conductivity, and solve problems on resistivity and conductivity. But before we continue, I still want to recognize the following subscribers who were winners of our first live quiz competition that took place on the 3rd of August 2024. So we have the following students from different departments from the University of Calabar. Here we have Okowa Prosper. He was the overall winner. And then Chukwuka Divine and Esther Young had the same point. Okowa Prosper is a student from the Architecture Department, University of Calabar. Chukwuka Divine, still the same school, a student of Computer Science Department. Esther Young is from Medical Lab Science Department. Our next live quiz is coming up first Saturday of next month. That would be on the 7th of September. The time is 11 p.m. and I want you to be part of that quiz competition. You too can be celebrated. Let's go to the order of the day. This one says, what is a cell? A cell is a single electrochemical unit that generates a specific voltage. In physics, a cell is a single electrochemical unit that generates a specific voltage. It contains of the anode. When they say anode, is the positive terminal of the cell, the cathode, the negative terminal of the cell, and what they mean by electrolyte. So an electrolyte is a substance that conducts electricity by allowing the movement of ions between the anode and the cathode of the cell. So that substance in that cell that helps in the conduction of electricity is referred to as the electrolyte. And the electrolyte could be either liquid or the form of gel or solid as well. So let's look at this diagram here. So you can see that what we normally call a battery is not a battery but a cell. Looking at this figure here, look at an example of what we mean by the word cell. So the moment we combine another cell such that we have up to 2, then we then call it a battery. Look here, this is a symbolic representation of a cell in physics. The longer side here is the positive terminal, while the short side here is the negative terminal as illustrated in the diagram. So the moment you combine up to 2 cells, you don't call it a cell again. If you have 2 or more cells, then you can call it a battery. And this is the symbol. Okay, so this is the picture and below is the symbol. We are going to look at summary of some mathematical expressions and then we go into solving of problems. Let's start with arrangement of the cell in terms of the series connection. So assuming we have cells such that we arrange that cell in series, the total EMF of the cell arranged in series is equal to the sum of the individual EMF of each cell. The total EMF, the electromotive force of that cell, of the cell arranged in series, is equal to the sum of the individual EMF of each cell. So if we have 3 different cells or more and we arrange it in this order, in the series order, then the total EMF of that very cell would be an addition of the EMF of each of those cells when you put them together, and it is illustrated in equation 1 here. Okay. So each of those cells have what they mean by internal resistance. Internal resistance is usually represented by capital R, so we can just say, small r, so we can just say that R equals to R1 plus R2 plus R3. So the Rn depends on the number of cells, and then you just add the internal resistance as well. But just note the expression because you don't know where you would come across this the next time. Parallel arrangement of the cell. In a parallel arrangement of a cell, all the positive terminals are joined to one point A, and all the negative terminals are joined to another point B. If each cell has EMF E, then the net EMF of the parallel combination is also E, that of a single cell. Okay, so if we have already considered the EMF of a series combination of the cell, now in terms of the parallel combination, the last sentence has made us to understand that the moment you combine all those cells together, they still have the EMF of a single cell, depending on how the nature of the parallel combination is. So you now see here the sentence say if each cell has EMF E, then the net EMF of the parallel combination is also E, which is the same as that of a single cell. So look at this figure so you really understand a series arrangement, what it and how it looks like, and a parallel arrangement, how it looks like. So you see that this one is just linked to this. Look at it. Look at it. Now look at the second figure. It's okay. For cells in parallel with similar cells, total EMF equals to EMF of one cell, but internal resistance of the cell will be, okay, so we have already said that the total EMF in terms of the parallel arrangement is equal to the EMF of one cell, but the internal resistance is given by equation 3 as shown below. So if you are asked to find the internal resistance of, let's say, a cell that is arranged in parallel, you use this expression here, arrangement of resistors. For combined resistors in series, we have the expression as shown in equation 4. We have that R1 equals R equals to R1 plus R2 plus R3 if we have 3 resistors. If we have 2 resistors, then the expression would be R equals to R1 plus R2. If we have more than one resistor, let's say up to 5, then we will also rewrite this expression, including the first resistor, second resistor, third resistor, fourth resistor, and fifth resistor, as the case may be. So look at this figure here below. It shows us a series arrangement of a resistor, how it looks like. As we continue, we are going to solve problems so you really get understanding of what I'm trying to say. For parallel combination of resistor, this is how it looks like. And this is the mathematical expression if you are asked to find the equivalent resistance of that arrangement. Then you use equation 5. Recall that V equals to IR, where V is the potential difference in volt, I is the current in ampere, and R is the resistance of that circuit in ohms. Okay, if we are to make I the subject of that expression, then we have that I equals to V over R. So please, if you don't understand how we got equation 7, you can still go back to your mathematics change of subject formula. That will really help you to gain mastery of what we are trying to say. Still from equation 6, assuming I want to solve for the resistance or make the resistance the subject, then I will have equation 8, R equals to V over I. But we also have that R resistance can as well be rho L over A as shown in equation 9, where the rho signifies the resistivity of the material. We'll define that as we go down. L is the length of the material, A is the area in meters square, and R is the resistance in ohms. Please, why I had to list all these and even go ahead to write it is to enable you understand what I'm trying to say. I used to say that the SI unit is a language. So in as much as I mention the quantities, the symbols, and their units, I want you to memorize the units. So whenever you see the unit, you would know specifically or directly what that quantity is all about. So if you see terms or units like ohms, you should know it means resistance. If I say meter square, that's area, meters length, and resistivity is ohms meter. Okay, so if we are to make resistivity the subject from equation 9, then we will generate equation 10. I am not telling you to cram it. I just want you to know how this could be deduced. So when you are writing an exam, you should be able to generate this expression on your own rather than memorizing or cramming. But we have that conductivity is a reciprocal of resistivity, where this symbol you're seeing here is known as the conductivity. And conductivity is the measure of the extent to which a material will allow current to flow through it. The measure of the extent to which a material allows current to flow through it. Okay, so I've already said that it's the reciprocal of resistivity. The SI unit is per ohms per meter. Per ohms per meter. Here we have resistivity. Resistivity is the resistance of a unit length of a material of unit cross-sectional area. The resistance of unit length of a material of unit cross-sectional area. Also recall that Q equals to IT, where Q is the charge, I is the current in ampere, and T is the time in seconds. So if the time is given to you in minutes, you should be able to convert it to seconds. If the time is given in kilometers per hour, should be converted to meters. If the time is given in minutes or hours, should be converted to seconds as well. Okay, also recall that E equals to I into R plus R. Equation 11. We are still going to apply this expression where E is the EMF in volts and I is the current, R is the resistance of that cell, and not just internal, is the resistance of the cell, and small r is the internal resistance. Please note that small r is the internal resistance and big R is just resistance. Okay, so let me strike this off. All right, let's look at this example. A wire carries a steady current of 0.2 ampere. Now look at that SI unit. It's telling you about the quantity. Don't forget, you write it down. A wire carries a steady current of 0.2 ampere over a period of 2 minutes. That unit should tell you something. What is the total charge passed through the wire in this time interval? What is the total charge passed through the wire in this time interval? In that question, we are being given a current and the time. Looking at this, while I'm looking at this, you can see clearly equation 10 can solve that problem. But there is something you need to do here, the conversion, because you can't just pick a minute here and begin to multiply that. You get a wrong answer. You have to convert that to seconds. That's what I was trying to say. So you observe the unit. Now, converting from 2 minutes to seconds, you multiply by 60. That value by 60 and you get 120 seconds. So I've done the conversion. The next thing is to choose mathematical expression. So I've decided to pick equation 1, Q equals to IT, and then substitute the given values. So the value for I, 0.2 ampere. You now pick that expression, this one I, and then this one is for T. When you substitute them into the expression here, you obtain your answer. Please, I would like you to do that one. Just solve that one and check what the solution is. Okay. Don't forget to write the correct unit of charge. This one is a classwork. It's similar to what I just solved. But in this case, you see that the current that is given two microampere. So all you need to do is you should know the meaning of what micro is. 10 to the power minus 6. So you are not just going to use 2, but if you're solving the problem, you will be using 2 times 10 to the power minus 6 ampere, because this symbol represents 10 to the power minus 6 as well. Then this one is in minutes. Of course, you can convert from minute to seconds. The moment you observe those two things I have mentioned, then you are good to go. Okay, so the question says a wire carries a steady current of 2 microampere over a period of 3 minutes. What is the total charge passed through the wire in this time interval? This is what you will see as your answer. So you use this as the reference frame to confirm whether you are correct or not. Example 2. Example 2 says that a cell of EMF 1.5 volts and internal resistance 2.5 ohms is connected in series with an ammeter of resistance 0.5 ohms and a resistor of resistance 7 ohms. Calculate the current in the circuit. Please, if you don't understand that question, I would advise you read it the second time before you join me, so I don't have to waste further time. Look at the options we're given below: A, B, C, D, and E. So let's see what we can do. Solution. From the question, EMF is given. I now have to list it down. So any problem that you come across, try to list out the quantities. The moment you list out the quantities, you will get the direction on which expression you are going to use. So we have decided to write this out. E equals to 1.5 volts, and then internal resistance small r equals to 2.5 ohms. According to the equation, internal resistance, look at it very well, and then we were given a combination of resistances 0.5 ohms and 7 ohms. So I just take this as R1. R1 equals to 0.5 ohms, R2 equals to 7 ohms, and from the equation they were connected in series. So I just went ahead to add the two together. Then that's the final answer. When you do that, 7.5 is the equivalent resistance, so that will give us a single R. Okay, so using the expression E equals to I into R plus small r, and then we'll now check what we have before we go down. We have E to be 1.5. We are to find I, calculate the current, so we don't have I. but we have R 7.5 here, and we have small r, this other one. So all we need to do is to solve for I. To solve for I from there, I believe you should know what to do from here. I wanted to allow you, but I will try this. Okay. I've done my substitution. This is how it looks like. I will now add 7.5 and 2.5 together. So we have 10i. So mathematically, it's not proper for us to write I10. So I decided to write 10i. And this is the right thing to do. 10i. Okay. Making I the subject here. Have 1.5 divided by 10, which is 0.15 ampere. Okay, so I think we have something like that here. Classwork. The question is projected here on the screen, so you are going to try your luck. That's the answer. Now, you are going to use this expression. The question says 5 resistances of value 0.1 ohms, 1.7 ohms, 2.0 ohms, 1.0 ohms, and 0.9 ohms are connected in series. Calculate the value of the combined resistances. So you just substitute those values using this expression. I would like you to give a try. It's just to add them across, and you now compare with the answer that is given. The answer is written in green color, so don't misunderstand it to be part of the question. The question there is indicated with the red ink. Example 3. Four resistors of resistances 4 ohms, 3 ohms, 1 ohm, 5 ohm are connected in parallel. Full stop. Estimate the value of the combined resistances. So the first one was in series, but this one is in parallel. So we are going to use an expression for a parallel arrangement of resistors. Okay. We now substitute the values accordingly. Then what we're going to do next is to find LCM. So far, I discovered that most students find it difficult to find the LCM. Here we have this expression. So what I'm going to do basically is to draw a line across, and then I'm going to find the LCM of 4, 3, 1, and 5. So let me write 4, 3, should ignore 1. Let me just write it there. It's just meaningless. And then 5 here. Okay. I pick the lowest number, 2. 2 can go into 4 here, 2. 2 cannot go into 3. I bring down 3. Let me bring this one down. 2 can't go into 5. I write 5 here. I still use 2. 2 into 2 here is 1. 2 can't go into 3, so I bring down 3. And then 2 can't go into 5, I bring down 5. The next number is 3. Bring this down. 3 can't go, 3 into 3 here is 1. Bring this one down. 3 cannot go into 5, I bring 5 here. So I now write 5. Bring this one down, bring this one down, bring this one down. 5 into 5 here is 1. So you now come here and multiply what we have by the side here. 3 times 5, 5 times 3, 15, 15 times 2. This is 30, 30 times 2 is 60. So you come here and write 60. We have 1 all over R equals to, okay, so all we are going to do next is to use the LCM and divide by the denominator. So we'll start with the first one here, 60 divided by 4. The first denominator here, 60 divided by 4 is 15. So you now write 15 times 1 is 15. Pardon my writing. This one is just a rough sketch. I will clean it and do the right thing. Then the next one is 3 here. So 60 divided by 3 is 20. 20 times 1, this numerator here, 20 times this one here, you still have 20 plus 60 divided by 1 is 60. 60 times 1 is 60 plus 60 divided by 5 is 12, and 12 times 1 is 12. Okay, so we have 15 plus 20 plus 60 plus 12, which is 107. So we'll simply say 1 over R equals to 107 divided by 60. Okay, so that's how we arrive at this point, and then we make R the subject of the formula. So in case you see me write something like that, you should not be confused at all. Okay, so look at it here, and we had 1 over R equals to 107 over 60. When you divide through, or you cross multiply, let's say, then you will have R equals to 60 over 107, which is the same thing as 0.56 ohms, the solution to that problem. Okay, so now that you have seen this, the method I have used, I'm going to give you study questions. So you are going to study these two. The first one says 4 resistors of resistance is 4 ohms, 3 ohms, 6 ohms, 5 ohms are connected in parallel. Estimate the value of the combined resistance. So you use the same method as the one I have just used, but also try and see. Look at the answer is written here. So you now compare your answer if it is right. This one says the resistance of a wire of length 100 cm and diameter 0.3 mm is found to be 3 ohms. Estimate the resistivity and the conductivity of the material. The solution is written here as well, and the expressions to use were listed in this tutorial, though I didn't solve something on this, but I would like you to give a try as well. Okay, so that's how far I can go for today's lectures. This is my channel Gmail, or as I still call it, email. If you want to contact us, you can contact us through this email. This picture is our home page, Supreme Online Lectures home page, and I want to use this medium to say thank you to our subscribers. And if you have been following us for a while and you are not yet subscribed, or you are new to this channel, this is what you will see. So I would like you to endeavor to click on the subscribe button. When you do that, it will appear to be subscribed, as you have seen here by my right hand side. The essence of subscribing is so that you get notified whenever I upload a new post. Okay, so thank you for watching, and I hope to see you in my next lecture. Have a wonderful day.